talk about stabilizing the NPM registry. I'll tell you first who I am to talk about that. I'm NPM's first DevOps hire. My name is CJ, SiegeBot on all the things. I've been working in Silicon Valley for a very long time, since 1987. My first employer was Silicon Graphics. I've gone on through a whole array of really fun startups since then. I'm going to talk about the registry part of NPM tonight. I'm going to ignore our website almost completely, though we have a website and it serves a lot of traffic. It's actually the most boring part of our infrastructure and the most stable. Whereas the registry, as you know, has had its issues with downtime. In order to explain how the downtime happened, first I'm going to talk about where NPM came from. I think it'll give you a little bit of a hint of why it had its little meltdown last year. This was a side project. This was Isaac's side project. He quit Yahoo and spent 2 months writing NPM. That's actually its first logo. Isn't it sort of charmingly geeky there? It's a 100% CouchDB app. It runs completely inside Couch. Its user model is Couch's user model. Most of the logic behind serving a package to you and manipulating the document information that you get is implemented inside Couch as JavaScript. Like all side projects, it relied on donated hosting, in this case from a company called IrisCouch. Because NPM was small, this donated hosting looked like a really great deal. Donated hosting for a package registry that has maybe 1,500 packages and a few people install from it every day. And in exchange, IrisCouch got some advertising. That looked great for a while. And then this happened. Two curves here. This nice smooth curve is the number of packages in the registry. That's the number over there. We're over 83,000 packages today. Back last summer, hovering around 30,000, looks pretty manageable, right? That jaggy red line is the number of downloads charted monthly. In January of 2013, we had about 13 million downloads in the month. To compare it with today, we had 17 million downloads yesterday. Wow. So, this happened. Let's see, when was November of last year? It was right around here, right before we started that meteoric rise. So, then we had this, which wasn't fun. Benign neglect worked for up to a certain point. The thing Isaac had written scaled up to a certain point, and then CouchDB fell over hard. And it's still, remember, a side project at this point. Nobody's investing any money in it. There isn't any money to invest. This is when the Scale NPM fundraiser happened. Nodejitsu had bought IrisCouch, so they were donating the hosting, and they ran that fundraiser. I think if I donated to that fundraiser, I wasn't an NPM employee at that time, because NPM, the company, did not exist. I do not regret donating to that fundraiser, even though I still don't have my t-shirt. Because I think the alternative would be that NPM just wasn't up at all in December. So that's what we got out of that. And I think at that point everyone knew, look, this can't continue to be a side project. So Isaac liberated some time from working on Node itself and started rewriting the registry. So for the first time, it wasn't a simple Couch app. It now actually had its first Node component. Weird, huh? Node registry, not actually a lot of Node involved in it. He put a CDN in front of it. So Fastly sits in front of that and provides a certain amount of caching and geolocation, so that you are no longer feeding all of your bandwidth through poor Nodejitsu. Puts, deletes, gets, go to Couch, and then this little node process called mCouch pulled all the binaries out and stuck them into a joint service called Manta. Manta is Joy's object store. This pretty much got NPM through the worst of it of that month. And then it got a little bit more complicated immediately afterwards. Turns out that keeping all the binaries in Couch really was a total disaster. When Isaac and Michael were first writing the registry, they were sitting in the same room as the main engineer on CouchDB, Leonard, and they said, hey, we're going to put the tar balls in Couch. Is that a good idea? And Jan said, nope, don't do it. And they did it, and it lasted for a few years. But at this point, disaster, down. So the binaries are out. And how we started getting them out is this complicated little thing. This is actually our second little node piece in the registry. It pulls the binaries out, shoves them into Manta, and then another node process pulls them out again and puts them into something called full-fat DB. This is skim milk. This is full-fat milk. Your registry with binaries and without. We had to do this because a whole lot of mirrors depend on the full-fat registry, the registry with all the binary attachments in it. Australia, for example, would be dead in the water without this to help them, or at least back in December, it would have been dead in the water without this because they maintained their own full mirror just so that their developers can have reasonable install times. And then over here, this bit in Iris Couch. A little bit complicated, but that's what the registry looked like. This was more or less holding up on under the load of people in January. And in February, the inevitable happened that we accompanied with funding. At this point, everything is 100% hosted on Joint, which Isaac had just been working for up to that point. We have a bunch of couches, load balanced by Fastly. Hand-built Couch and SpiderMonkey. SpiderMonkey is Couch's JavaScript engine. Because we're running on SmartOS, which is Solaris essentially. Nothing works out of the box. We have to hand-build most of everything we're running. Automation by a bunch of bash scripts. So pretty much every server we run is a lovingly artisanal, handcrafted Unix system. And Twitter tells us when we're down. Hey guys, you're down. Oh, sorry. If everyone was asleep? Yeah. We stay down until somebody wakes up. This is obviously not actually any good, right? At that point, that's when I'm hired. I'm one of the first two non-founder hires at NPM. There were 5 of us at that point. First thing I do, pager duty, hello, yes, we're all gonna get woken up. And Nagios is all hooked up and monitoring the basic host health. So at this point, we're monitoring just the basics. I have no idea what this service is doing, what questions I should be asking about how to keep it up. We have maybe 10 hosts total, but we've still got downtime happening when service processes fall over, couches stop replicating to each other. Why, we don't know. All that we know is that our pagers go off. The funding announcement was lots of fun because literally the very next day we had somebody say, hey, found some security vulnerabilities. Do you have a bounty program? How about that bounty? But literally, none of us are working for paychecks at that point because we don't have anything set up, but bounty hunters, okay, great. They actually found some pretty serious security holes in the website. And this leads indirectly to our last truly major outage. Our cert was compromised, so we had to replace it. This turns out to be trickier than you'd like because old NPM clients were relying on a self-signed cert. And we did not replace that cert with one that the old clients knew how to trust. Turns out there's a hell of a lot of old NPM clients out there, unupgradable. Things like in Amazon's Elastic Beanstalk, where you rely on that for your deployment, but you can't actually touch what the tool chain is. So we broke a whole lot of people for a day until we rolled back to the possibly compromised cert and then replaced it with one that had the right authority chain that the old clients could trust. That was the last bit of outage. I would say it was really, truly, we screwed up and made everyone's lives miserable. Sorry. What we did immediately after that was hire Lyft Security for an audit. This was really worth it. Like side projects, it's a side project. It's written by one guy plus a handful of people making PRs on GitHub. It had problems. We found them and fixed them pretty methodically in those first couple of weeks. User framework, that's my other piece of advice. You tend to have fewer problems if you're not handling everything. If you're using something that somebody else has worked on and looked at and tested, this is a source of a lot of our early issues. So once like emergency mode is out of the way, that's when we really start the actual hard work. Stabilization phase 1, it's all reactive because none of us understand the system we're working on yet. Isaac does, but he's still in the middle of like transferring all that knowledge to us, and we barely even know what questions to ask. The monitoring starts to go from just like, is this host up? Is it serving HTTP? To, is the right process up? Is the right process responding within a reasonable amount of time for our application? Here's where we start to figure out like what the right questions to ask is about a service. I think this is sort of an interesting problem because I walked into an existing complex running on the ground service. I got to figure out how it works and how to make it better without disturbing it. Because at this point, it's pretty clear to me we can't afford any more outages. Every outage we have shakes people's confidence in this. And this isn't good. This is like literally what I'm hired for is to make this stop happening. But hey, the great thing is Twitter isn't telling us when we're down. We're figuring out when we're down pretty fast. We're still down. I don't like that. Stabilization stage 2. What do I call this? We're starting to have a clue phase. We hired our second DevOps person, Ben Coe, who's pretty awesome. It's really nice to have help and a second pair of eyes looking at everything you do as a team. We've figured out where our recurring problems are. Here's an example. Couch replication is the heart of all of our architecture. Couch is really awesome at this. But replication will fail if Couch hits its retry limit. And it will do that pretty often if you're replicating across data centers. By across data centers, I mean like one Amazon region to another or Amazon to Giant. Anything where the network is pretty flaky, and that means anything that isn't on the same rack. So Couch replication was just falling over, and we had an alarm for it for a while. Great, Couch is falling over. Half of our users are getting 503s and they can't install anything. But then we figured out, it's happening because Couch replication is failing. Why is Couch replication failing? Networking, okay. Now we can check for it and heal it right at the moment so that the downtime, it doesn't even happen. We don't get woken up for our most common error. It just fixes itself. It's starting to feel good. I'm starting to have enough redundancy everywhere. I don't have one of anything anymore. I have 3 of something. So if something falls over, I'm okay. If 2 of those things fall over, I'm still okay. You can still install packages. And the next thing we did was get some real automation in. I don't know how many servers you guys wrangling. If it's more than 4, automate. It's probably worth it. Our night shift is bored. We have a spanning the globe set of Node developers doing on-call ops for us when we're asleep. Pacific time, we have somebody in the Netherlands and somebody in Thailand, and they started to get bored, which I like. I like boredom. If you're an ops, boredom is good. So this is what everything sort of looked like in June. Yeah, last month. You come in on the CLI, you hit Fastly still. You notice actually what we've done is split out a bunch of stuff. We have a machine whose whole job it is to take writes in, and it's provisioned for that. It's got a nice fast disk. Pound is terminating our TLS, it takes all the writes. Skim worker is still there, yanking all the binaries out. This is my first bit of Node that I got to write for NPM, was rewriting that. Tarballs, now not served by Manta, they're served from a file system behind Nginx. That's working out really well. We have 2 of those. That handles all the load just fine. And we got a pile of couches. Way too many couches at that number. It's horrible. We have, this is skimdb.npmjs.com, public replication point for the registry data. And then we still have that front guy with all the attachments, just in case you want your attachments and you've got like a ½ terabyte of disk free. There you go, all yours. So it looks pretty much the same. So that it totally isn't. We're now 100% on AWS. We left Joint during that time. We're running on Ubuntu Trustee now. Last month we had about a 70-30 split between West and East. I didn't like that very much. We'll fix that. And we're 100% automated with Ansible. We tried a little chef automation for a while, but it was horrible. Puppet, meh. SaltStack rolled around crypto, did not talk to me. Ansible works pretty well. When I counted on Sunday, we had 52 running instances on Amazon. That was actually probably a high watermark for us. We're down about 35 today. All of this was accomplished without you guys noticing anything. I would spin up a bunch of stuff, have it running alongside the other, like beat match, fade the old stuff out and fade the new stuff up, and then just keep rolling on through. I think that's a pretty typical operation approach. Run two things alongside, and then just smoothly switch over. Here's what we use Fastly for our varnish caching. This is really pretty huge for us. The biggest expense for NPM that I absolutely cannot touch is how much bandwidth gets used by you all as you install packages. Tarball bandwidth is pretty huge. They tend to be small. The average one is, 10K max, but they can get giant. I installed a package the other day where somebody had thoughtfully included all of Elasticsearch as part of the test harness for it. Why is this package 400 megabytes? Oh. Nginx to serve our static files. We still are, terminating TLS with pound, which is a really simple reverse proxy. Does that one thing pretty well. All of the registry data is still in CouchDB, which is still our database. Probably will be for a long time. Nagios and PagerDuty. Nagios is loathsome. If any of you know anything better than Nagios, I want to know, because it is horrible. But mostly we don't look at it. We just have PagerDuty pages. This one's pretty exciting for me personally. During my free time, I've written a bunch of stuff to pull metrics out of everything that's going on. I miner logs for metrics. I have cron jobs running and pulling CouchDB and pound processes for metrics and shoving them all into InfluxDB and then graphing them in Grafana. That looks like this, which is pretty cool. These are live from our dashboard on Sunday. So I look at like how efficient our caching is doing, package downloads per minute. It's kind of noisy at that level, and that one's for fun. Grunt versus gulp. Grunt is way winning, way popular. So I like this a lot. It's one of my favorite things. Ansible. It's important. This was a fairly new to ops, and I knew that this was the thing to do. Like, this is what you're supposed to do. You're supposed to automate so that you never touch your servers. It is so valuable. I don't care if a machine falls over anymore. I can just spin up a new one. I can push a button. I can deploy it from chat rooms, our Slack room. We just say, Hermione, deploy the website, and Hermione, our bot, deploys the website. This is awesome. Do this. If you don't have automation like that, invest the time in it. Yeah, weak points. There are always weak points. We have some single points of failure. Fastly is a single point of failure for us. They had a pretty major outage last month, and you guys are pretty lucky because it was on a Friday night Pacific time, but not everyone was very happy about that because they were just down and there was nothing we could do. We also have only one write primary. If that goes down, you'll notice it until I can spin up a new one. Still looking for an off AWS backup. I back up everything with Tarsnap, which is mad science stuff, but Tarsnap is secretly still on Amazon. So if Virginia catches fire, I'm in trouble. It's expensive to run too many CouchDBs. I So it shows you that number 20. I was getting 120 requests a second out of Couch. That was terrible. Terrible. Too entangled with CouchDB. Like, why is our user auth is still Couch? It means we're really tied to Couch and we can't do anything that Couch can't do. But that's an application level thing, but I feel the pain operationally. I also think it's complex in weird places. Like, this is what happens when you publish a package. Package comes in, goes into Couch, tarball and all. Couch notifies the skim worker through the changes feed. Hey, new package. Skim worker says, oh yeah, new package. Just take a look. Does it have any tarballs? Yes, it does. I'm going to grab the tarball. I'm going to shove it off into a bunch of places, to the Nginx package servers, back up to the spot, and then I'm going to put the package back into Couch. This is silly, right? That tarball should get stripped off on the way in for whatever it is Couch, because Couch is generating a changes feed item for every single thing you do to a package document, and that just generates this spew of package changes. It's very silly. I'm going to say some nice things about Couch. Yeah, everyone hates their database, right? Like, you want to hate a database, put it into production. And, you know, I hate Couch. But I'm going to tell you what it does really well. Couch replication is completely solid. You want a copy of the registry? I'll tell you how to get a copy of the registry. You spin up CouchDB. You point its replication at skimdb.npmjs.com. And half an hour later, you're going to have the whole registry. It is literally that simple. And that is the basis of like half of our architecture. How do we replicate Couch internally? Like that. It works. It doesn't fall over now that we understand how to keep it up. It stays up. Its changes feed drives everything too. And that has also been completely reliable for us. A package arrives, something happens, Couch tells us we can act on that and do important things with that. We can reliably back up or move stuff from one place to another. So this has been a completely rock solid building block for us. It's really terrible at serving tarballs, let me tell you. It was really cruel to make it do that because it's not any good at that. It's also really terrible at doing anything you would do use a relational database to do. You want to know what packages this user has published. Couch can grind that one out for you, but it'll break a sweat while it's doing it. It doesn't like it. It's not what it's good at. So now that we're mostly not making Couch do things it's bad at, I'm happy with this. Next thing I gotta do is make it cheap. I think startups need two things. They need somebody who's really focused on revenue, and they need someone who's really focused on not spending money. And right now, I'm focused on not spending money. So, in fact, the diagram I just showed you how the registry works, it's completely untrue. We completely changed it today. So we rolled out really solidly new architecture that uses a whole lot fewer couches. This afternoon before coming here is like shooting couches in the head. Boom, 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 down you go, because we don't need you anymore. We're no longer terminating. It turns out they're running your TLS termination and Couch in the same box. Not so hot. They contend for the CPU. So we're using hot proxy in front. Hot proxy on its own box, terminating TLS for a bunch of couches. The couches have now had room to breathe, and they do a lot better at serving new requests. So that's sort of what it looks like today, almost the same. The really great thing about this is I was able to finally balance between US East and US West. So that if Amazon melts down, I can probably keep serving the traffic without falling over. I really like redundancy. I really don't want to be down for you guys ever again. So that's not fun. When the registry's down, I can't install NPM packages myself, so I'm against it. This is still up. This is going to be up forever. Couch will probably be part of our stack forever. This, on the other hand, full fat, that's going to go away. It's probably actually past its shooting ahead time. This is by far the most expensive thing in our architecture because full fat DB is pretty PB. Half a terabyte at least, probably more if you actually want to run comfortably. That's pretty much it. My goal is to give you guys a utility. I want you to not think about NPM ever again. I want you to just use it and have it work. Do all this stuff. That's it. Any questions?
So I just have one question. I saw that you guys are now serving the packages from an Nginx server, right?
Mm-hmm.
Is there any reason why you didn't just go through S3 or something since you were already on AWS?
S3 is not a CDN, and it's probably actually going to be a lot slower to serve packages from S3 than through a machine that's built to do just that. Also, I want more control over that. I want to be able to make statements about the caching and stuff. I think you could do that with S3. S3 is not actually something you should be serving web files from. I mean, Amazon has a CDN, use that instead. Anything else? No questions?
What happens when a full stack goes away? What does that mean? Like for the ecosystem, is that the mirror is going down? Is that?
If you want to run a mirror, you can. You can construct a full width tarballs mirror exactly the same way we construct full fat. All the source software we use to make that happen is open source. So what you would do is you would spin up a couch, and then you would spin up this full fat worker that just takes changes from SkimDB and then refattens them with the tarballs and shoves that into couch. That is exactly how we construct full fat to begin with. It's known as if you need it, if you're an Australian, you still need it. You should do it that way. That won't go away.
So you said that it would be tough to move off the couch because of the user authentication.
Yeah.
What if you were to do it, how will you do it?
There's two things. There's like the document that's in couch is not the same thing that gets served to you when you say NPM info request. You get a document back, and that document is actually generated on the fly by couch. It's one of the reasons why request per second is a little on the slow side. So I would have to replicate that logic. There's a difference between what we're storing and what we're serving. We store more metadata that most of these what you don't care about. So we'd have to replicate that. I think that's the easy part. The user auth part is harder because it's more tangled with everything. For example, how the website auths you is relies on the fact that you've got couch auth, so we have to fix that. We'd have to make completely certain that we didn't touch what the client saw. We would have to replicate the API to the outside world. Most people track the latest NPM client, not everyone does, and backwards incompatible changes there are not something you want to do because that hurts people. So two things, off trickiest, logic behind displaying, easy but has to happen. I think if you do that, you just need to have over a couch. No
Sure.
pressing needs to do it though.
So another quick question. If you do like an NPM search to like look for packages,
Mm-hmm.
is that actually executing a search on the couch database, or are you using like
We're using
Solr or
Elasticsearch.
Steam or something? Okay.
Elastic, so it's the same, driven by exactly the same thing that drives everything else. Couch has a change of speed, we follow that, and then we shove everything into ES.
Okay.
That is our summer project for our intern, making that a heck of a lot better, so it should be better soon, which would be nice.
What is your experience with that been so far? Like how stable is the Elasticsearch?
Elasticsearch loves to throw away data. You should never use it as a primary store, and you should plan on shoving more data into it regularly. I hate running Java in production for a bunch of reasons. It's like, hello, how many file descriptors would you like? All of them, please. You limit infinity. But what we do, we don't cluster ES because that's where I think most of the trouble happens. We have one per web page, and it's been pretty well behaved in that configuration. Sorry, we didn't talk about org stuff at all.
Anything else?
Awesome.
Thank you.
Thanks for letting me talk.